FastMCP 3 implements component versioning through a client-server interaction pattern that enables multiple implementations of tools and prompts to coexist under a single identifier. The system employs semantic version comparison to determine the highest version by default while allowing explicit version specification through method parameters. The upcoming code artifact will demonstrate how a client initializes a connection to a FastMCP server and invokes versioned components, showcasing both default behavior and explicit version targeting through the call tool and getPrompt methods. From FastMCP import client. Async with client server as client. Hash call the highest version default behavior. Result equals await client. Call tool calculate x 1 y 2. Hash call a specific version. Result v1 equals await client. Call tool calculate x 1 y 2 version equals 1 0. Hash get a specific prompt version. Prompt equals await client. Get prompt summarize text version equals 1 0. This code demonstrates FastMCP3's versioning system for tools and prompts, allowing clients to target specific versions rather than always using the highest available. The pattern enables API versioning within a single codebase, eliminating the need for separate deployments for different client versions. The implementation uses an optional version parameter in both callTool and getPrompt methods. When unspecified, the client automatically receives the highest version determined by semantic version comparison for PEP 440 versions. When specified, the server executes exactly that version, raising a not found error if it doesn't exist. This approach provides explicit version control while maintaining backward compatibility by default. The versioning system supports gradual migrations and API evolution. By allowing multiple implementations of the same tool or prompt under versioned identifiers, teams can deploy new versions alongside existing ones. Clients can discover available versions through metadata and choose appropriate versions for their needs, whether for backward compatibility or accessing new features. The strict separation between versioned and unversioned components prevents ambiguous filtering scenarios. Let's break it down. From FastMCP import client. Imports the client class from the FastMCP module, providing access to FastMCP's client functionality for making calls to the FastMCP server. Async with client server as client. Establishes an asynchronous context manager for a FastMCP client connection to the specified server. The async with statement ensures proper resource management, automatically handling connection, setup, and teardown. The client instance is bound to the variable client for use within the context block. Hash call the highest version default behavior. Result equals await client. Call tool calculate x 1 y 2. Asynchronously calls the calculate tool using the FastMCP client with parameters x equals 1 and y equals 2, executing the highest available version by default since no version parameter is specified. The result of this tool execution is stored in the result variable. Hash call a specific version. Result v1 equals await client. Call tool calculate x 1 y 2 version equals 1 0. Calls the calculate tool with parameters x equals 1 and y equals 2, explicitly requesting version 1 instead of the default highest version. The result is stored in the variable result v1. Hash get a specific prompt version. Prompt equals await client. Get prompt summarize text version equals 1 0. Asynchronously retrieves the summarize prompt version 1 from the FastMCP client, passing a dictionary with a text key containing the string as input parameters. The version parameter explicitly requests this specific implementation rather than defaulting to the highest available version. FastMCP3's versioning system enables seamless API evolution through a unified client-server pattern. The client initializes a connection via the Client Context Manager, then interacts with version components through callTool and getPrompt methods. By default, these methods target the highest available version, determined by semantic version comparison, ensuring clients automatically benefit from the latest implementations. However, the optional version parameter allows explicit targeting of specific versions, providing precise control over which implementation executes. This dual behavior, defaulting to highest while supporting explicit versioning, balances backward compatibility with forward migration. The pattern eliminates the need for separate deployments by allowing multiple versions of tools and prompts to coexist under the same identifier, with strict separation preventing ambiguity. The result is a system where clients can discover available versions, choose appropriate implementations, and migrate gradually without breaking existing functionality.
The server hands you calculate's newest child when you ask for nothing. Empty hands cradle the future.